Any questions?
So it's actually a week. You get a week, right? Late days.
Okay, so yes, that brings up two things. One is a late policy, right? Yeah, you can get up to a week, except if I talk about the solutions in class, right? Because if, for example, I grade this over the weekend, and on Tuesday I turn them back and talk about, right, how I graded it, it's too late to turn it in, right? Because and then you're like, okay, I'll just you had an unfair advantage to people who did turn it in time because you get the feedback, right, of what everyone did wrong.
So is the print and order stuff print in priority order? Or? The heap has a different print.
Well, there is my intent, but I also have to look at what I wrote my words down, right? The intent was sorted order, but I forget what I said, right? So I have to go back and look at that. What? The other issue is the people in class, the information probably isn't relevant right now because you've already turned it in. The question is, if you want to turn it in late, how do you do so? Well, you just slip it you slip it under my door of my office, the old-fashioned way. Morning exercise, come to school and what's that? I live close to campus. Yeah, you don't need to print out. Just print the code is fine. This assignment is not that big, right? It's pretty small. I should be able to detect whether or not your tests are completely fake. Any other questions? Should you have normalized it? What happens if you don't normalize it? You'd have a stronger bias on the bigger number. That's right. What? Any other questions? And just so you can let your friends know who haven't turned it in yet, my plan is to grade them over the weekend and then talk about the solution issues I found on Tuesday. So if you know someone who is going to turn in late, tell them they have until Tuesday to do so. I guess the other thing is to remind you that next Monday is the last add drop day, right? So whatever classes you're in, Tuesday morning, you're in for the rest of the semester. There's also a number of other deadlines that happen at the same time, right? If I graduate this semester, so I want to go back and cover sort of what jumped over last time. Dilbert. We talked about this briefly. The two things about old programming we learned from Dilbert. One is never do something you can get someone else to do for you. This really is don't build huge, big classes, right? So you can break it up in smaller pieces and figure out what those pieces should be, right? So that you use those classes to do things for you. So in the old world, we talk about capsulation, right? One of the things about classes, it encapsulates things, right? But there's also responsibility that, what does a class do, right? And so, Alan and I says, yeah, encapsulation talks about responsibility because you're grouping, this thing should do this, right? I have a heap. This is what a heap does. Here's the operations, right? And I'll calculate those operations in a class. And so when we're talking about classes and capitalization, we're also talking about who should do the work, right? And so a lot of what you end up doing is when you get classes is do I do it in this class or in that class? Which class should do it, right? And so the second thing, right, in principle, learn from Dilbert is, avoid responsibility, right? Pass it on to other classes. And so here's an example. Say I've got a search tree, right? I insert things. Well, do I do the work or do I tell the node to insert the new element, right? So using this responsibility, like, okay, I'll have the node do it because now it says avoid responsibility, and so the ternary tree is like, okay, I could do all the work, but hey, I've got someone else who can do it for me, so I'll let them do it, right? So far, so good. Maybe, yeah.
So does that mean that I have too much work and distribute?
Yeah, you don't want to have one class that does all the work, right? So one extreme you see is you've got a bunch of classes, and they're just basically structs, right? They have fields in them, and then getters and setters, and this class has fields in them and getters and setters. You're like, well, if it's just getters and setters, where's the work being done, right? Oh, and then there's another class that's really big. It does the work, right? So we want to spread the responsibility out, right? That one big class is often called the God class, because it knows everything. It has to know I have to grab this data and do this with it, and then put it over here and do this with it. And one way you can tell if you've got a God class is if you've got a team, which class does no one want to implement? Like, oh, that's going to be really hard. And the other class is like, oh, I can do that in 5 minutes. And I'm done. Come on, yeah. Did you get your class done? I did 3 classes already, and aren't you done yet? Right? Um, different people define class and object different ways. Um, this is pretty standard, right? That a class is a blueprint for objects, right? It tells you what data and operations or attributes and functions, whatever you want, right? An object, right? Some people say it's an instance of the class, but it's an allocated block of memory with the fields, and right. And there's different languages have different syntax and different ways of defining a class, and this is Ruby, but Python's like this too, in the sense of we can just I've defined 2 fields using the Java syntax or terminology, X and Y, and I don't have an explicit declaration for them, right? Python's like that too, right? You don't have to declare in Java and Swift and Kotlin. There's syntax where you have to declare your fields, right? Whereas in Ruby and Python, whenever you want a new one, you just, assign a value to it, and it's there, right? Another definition is first class dynamically dispatched behavior. It doesn't talk about syntax, it's just, it talks about behavior, right? It does things for you. And it talks about dynamically dispatched. What does that mean? Let's see, I should have someplace. Happened to my black one. No, so we'll do red. It's all empty. Let's say I got class A, right? And then class B and class C, right? Yeah, I mean, and so I have 3 classes, right? A and B are subclasses of, or B and C are subclasses of A, right? And now I have some var X is of type A, right? And now I say new, and I'll leave that blank, but I put something in there, right? I can say A, B, or C, right? And now when I do X dot foo, which foo method is called? What's that? What's that?
The variable type A, right? So it's not like inheritance doesn't go down unless, so it would have to.
No. If I've got a foo method here, and I override it here, and I override it here, right? Now, if I've got 3, and say this one just return A, return B, return C, right? What's that going to return?
I assume that it's specified the type of the variable.
Yeah, I'm determining the type, right? So this is Java, right? What happens in Java? It's strict type, but at runtime, what Java does, and what Kotlin does, and what Swift does, and Python does, and Ruby does, and Smalltalk does, and Scala does. C++ is trickier. What's going to happen is at runtime, you dynamically dispatch the behavior. What does that mean? It means at runtime, you go to X and say, oh, what class is X? What's this class? If the class is C, then you look on the C class, does it have a foo method? Yes or no? So then you call that one. If X was an instance of B, you would call this one. If X is a instance of A, we'd call that foo. Now what this line does here, right? By declaring X to be of type A, that determines in most languages what method you can call on X. I can only call methods on X that are defined in A. Not true in Python, right? Python is different. Python and Ruby are different in that respect. Python, Ruby, and Smalltalk are completely different in that respect. But all the other ones, right, declaring this to be of type A, that fixes what methods I can call on it, but not where the methods come from. That's what they mean by dynamically dispatched, right? No, if I say new, not this one, not this one. No. But yeah, I know. If I put this back in here, the next class I'll pull it out again, right? If I put B there, B is going to be returned. No, no, why is that? This is perfect. I mean, the syntax is not Java, but if I change the syntax to the Java type, it's not a problem.
B and C are both.
Yeah, B is a subclass of A. So the question is, can I now force this to be A's foo function? That that depends on the language you're dealing with. In C++ is possible. In Java-like languages, you can do that in B's foo function, but you can't do it from outside the class. Yeah, it does. Yeah, but then there's also scoping rules. You can do weird things like, well, first of all, to get dynamically dispatched behavior in C++, you have to have your base class has to be virtual, and you have to have pointers, right? Otherwise, it's all static. And even then, there's some scoping rules you can use to say,
you assign B class to unless you just ask.
no, as long as it's virtual and you have a pointer to the object, then you get dynamic dispatch behavior in C++. That's one reason why not to use C++ in this class is because it's more complicated. Well, in Swift, external names in Swift are part of the function declaration, right? And so this behavior only works if this function overrides that function, right? And if they have different names, then it's not overriding different function. So that's what they mean by dynamically dispatched. First class is built into the language, right? Right, and behavior is just a collection of name operations you can perform, right, on that thing. And you can invoke them on clients, and they can share hidden pieces, right? So class A, B, A can have fields that you can then share among the operations in A. That's all they're saying. Yeah, yeah. What this definition is trying to do is, instead of sort of being language specific, like, well, the class is defined by class name curly bracket, they're trying to bring out, oh, what are the important features that we really want a class to have, right? Julia is another language. They don't use, you never say class, right? Because of the way they construct it, but that doesn't mean they can't satisfy this definition. Right? Different objects can implement the same operation names in different ways, right? So I had class A, B, and C implemented, and now at runtime we decide which one to call. So the definition is more functional and tells us what behaviors we get, right? And in first class, so the question is dynamic dispatch different than overriding? The reason you can't differentiate them is because you're stuck in Java world. Python world is completely different, right? In the sense of, in the Python world, you never say the type, right? And now if I have a class D over here, right? Not related to A or B, it's just completely unrelated class, but I just happen to have a foo method in it, right? I can now do that. And it works just fine in Python and Ruby and Smalltalk. And so here, overriding doesn't come into play, right? Because this foo method does not override anything. Yeah. Right. Right. And so if you've just programmed right in Java, then dynamic dispatch really only happens when you override methods. But there are languages, right, that we don't need to do the overriding to get that dynamic dispatch. So Alan Kay was this guy. He got his PhD, I think, in 1969 from the University of Utah. And at that point, computers were big, right? A computer would not fit in this room. It's too small. I mean, by big, I mean physically big, right? No, they were just physically large. And his PhD thesis, he basically asked the question, what happens, what do we do when I can, you know, reach in my pocket and pull out a computer? Really, I mean, that was his PhD thesis. You know, what do we want to do on this device that I can pull out of my pocket and carry around with me? I'm not going to feed punch cards into it, right? So what interface is it going to have? What type of functionality do we want? That was his PhD thesis. And then when he graduated, he went to Xerox PARC, and the goal was, well, let's just build that computer. And so they did build some very nice computers that were way ahead of their times, but he spent 10 years working on a language that could run on that computer called Smalltalk. That became known as the first object-oriented programming, right, language. And so Alan Kay now is known as the father of object-oriented programming because Smalltalk was object-oriented. He's also known as the father of the PC because he was like, it has to fit on your desk. I mean, come on, Kay. And they did that. Right. He's also a very smart guy, and he has strong opinions, and he likes to state them in a way to shock people. Right. So he now regrets using the word objects. Well, what he complains about is that people are focusing on the wrong idea, right? For him, it's messaging, right? How do you get something done? You send a message to someone else, and then they do something for you and give you the answer back. That's what his intent is, right? Right. And local retention and protection and hiding of state process, right? You don't want all the data to be global. Kind of, yeah. And then late binding of all things. Yeah, and that's a problem, right? You know, in Smalltalk, first of all, you wouldn't do that, right? And actually, originally, what you would do is you would say X. No, it's okay. You just put a space, right? Because this becomes a message you're sending to X. So they didn't want to use that dot because it's more like it's attached to it.
X is still the object.
X is still an object, right?
It's still a function defined in the class.
Right. But that's just implementation details of what he's trying to get at, right? He really means the idea is how to get something done. You send a message, right? Now it turns out that there's a system called the actor system that I think achieves these goals much clearer, right? Because you really do send a message to. You have a bunch of actors, and you'll send a message to them. They've got a message queue, and they'll grab something off the message queue and process it, and then they will then send another message to someone else, maybe back to the originator saying, "Here's your answer." But it really brings this messaging idea to the forefront, right? Yeah, so there's messaging systems are like this. Certain event-driven things are like this. But this message, it doesn't have to be to the ether, right? It can be to, I can send you a message, right? I don't have to send it to everyone, and then they decide which message to pick up. But this is the idea he was trying to get at, right? that we want to send a message to something to tell it to do something for us.
This, and like, just, there's like the way I'm kind of understanding this is since you're kind of, it sounds like you're kind of treating the function of the function to be an independent operation of the object you just set it to. I don't, so let's say like you had y foo instead of x right there, and y is a, b, or c. What happens if you take this function that exists and we have it defined somewhere and sends it to an object that doesn't? I mean, presumably it'll produce an error. It'll be the stack tree.
Well, in Python, you get an error, right?
I'm always thought of like the functionality of objects as something internal to the object that goes out. The way you're presenting it here makes it seem like the function's out here and it goes into.
Well, yeah, do this for me, right? Right. I have a task. I want you to do it for me. And I'll send you a message saying, "Can you please do this for me?"
And it even goes outward.
Right.
Okay.
Right. So the question is, isn't it just semantics? In part, but not entirely. It's a different way of looking at things, right? Um, and if you only come from the Java world, it's hard to see that because everything is fixed. But in Smalltalk, you can do things like, well, what happens if I send the foo message to an object that doesn't know foo? I can actually program the object to handle anything I want, right? And then redirect it. Um, and so it won't blow up. It'll say, okay, foo, I have no idea what foo is, so I will do this to it and return an answer. Yes, right. And so his idea is this idea of messaging, right? It's a way of thinking about how we want to get things done, right? In some sense, but it's also you want to say program, right? Most people, when you say what's a program, you say, oh, I need to start with a main, right? And I do this, this, and this. So in his world, a program is you set up a bunch of objects that are connected somehow, and then you may start off by sending a message to one of the objects, and then it does something, and then it starts bouncing messages off other objects, right? And this whole thing propagates until it does what we want it to do, right? He wasn't necessarily acting in an asynchronous way, right? Um, the actor model does do it all asynchronously. That makes it clearer, right? But so in his mind, a program is a bunch of objects that you work together and you send messages back and forth, right? So the way you write a program is what objects do I need, how they interact. And so your main, as most people think of it, is just creating the object you need and then connecting them and say go. That's it. The objects. And then you say go. And then they do whatever they're programmed to do.
Just like from the standpoint of perspective, it kind of shifts the programmer from like knowing what's inside the object to just kind of asking it to do what it knows how to do and not really worrying about how it.
Exactly. Yeah. I mean, when you
Outside anything rather than that.
do you know how an array list works? There we go, right? And you've used it, right?
Nope.
You never used an array list?
So took the intro and intermediates. It didn't go.
What's that? Sure. Python's a mess, yeah. No, what's that? Yeah. But you know how it works? Yeah.
I know what it does.
You know what it does. Exactly, right? And that's the goal is, right? Once you create the class, you don't need to know how it works, right? You know, what does it do for you, right? What message can I send it? That's it, right? That's the goal here.
Yes, this might be kind of a question of like the implications of this perspective change. Like object is supposed to be.
Yeah, and that's part of what we have to work on. But you know, the goal is a class represents an abstraction, and we have to ask what behaviors belong to abstraction, right? We get it work once we implement it. We can basically treat it like a vector or array list, right? It's just it does what it does, right? And we want it to be independent of other things.
Like looking at our classes and objects at that layer of abstraction, wondering how it works underneath.
Right.
Just the class can do
To
and trust it correctly. Just use that information. Unless
yeah, I mean that's what you do with the entire Java API, right? Or the Python API, or right? What's that? Or the class we should wrote, right? Um, right? So the whole thing is how do the modules communicate, right? Rather than what their internal properties and behavior should be, right?
communicate, you mean anything or just specifically?
Well, how do you interact with an array list or a vector? Right. So that was his focus, right? It's not how the class works. I mean, the focus should be on I build a bunch of building blocks and then I can use them and connect them together to make a bigger structure, right? Okay, so far so good. Yeah, subtraction is just essential ideas, right? What's important? What are the important features? What are the common patterns, right? Encapsulation is just putting things in a container, right? And then information hiding, right? These are the three big things class could talk about in old programming. Is like you say, okay, we're going to use abstraction to figure out what we want this thing to do. We encapsulate them into, right, a class, and then we want to hide the internal workings so that we can forget about them, right, and just use them like an array list or a vector.
Like how often do you go to the foundation of your house, right? You just know that it works and you
right. Yeah. Or a better idea, electricity is a better one, right? Because you actually do something with it, right?
Right.
Turn the lights on, turn them off, right? Right. Or even what that switch does. How does it actually turn on the lights, and what does that mean? And right? Right. So a class, represents an abstraction, encapsulate data and operations that belong to that abstraction, right? And then we hide the design decisions, right? Do you want to use an array to implement your heap, or do you want to use a link? We can use pointers, right, and build a structure that way, right? And we should be able to go in and change implementation from one to the other, but not affect the interface to it, so we can still use it the same way, right?
Design function shouldn't be so specific that you like a context change rewrite.
Yeah, it's an abstraction, right? It, right, right. And the outside world, I mean, you should be able to change how you implement those methods, right? As long as they provide the same behavior to the outside world. Um, some simple heuristics about classes, right? One is you want to hide all the data inside the class, right? That's part of the details. We don't want people to know whether you're using an array or an array list, right, or a vector or pointers to implement your priority queue, right? That's implementation detail. So we want to hide all that data. Another one is a class should represent an abstraction, meaning one, right? It's a priority queue, it's a stack, right? And data and behavior should go together, right? Again, if you've taken an undergraduate course in OO, these is just standard stuff, right? So there are some things that sort of break this. A data class. What's a data class? It's a struct, right? It has data, no operations. And last week we looked at, well, what happens if I have a struct or have a class that has fields and getters and setters, and that's all. Well, and functionally there's almost very little difference there, right? A utility method, what do I mean by that? What I mean by this is I have a class, right? And so if I'm in the Java world, I have to have a class. If I have a function, it only operates on its arguments, right? So if I have a function that doesn't use any of the fields of that class, I can move it anywhere, right? And still call it. I can make it a static method in Java and it'll still work because it doesn't interact with the data in that class, right? Right. So utility method does not access any field or data member, or whatever you want to call them, and it just uses the parameters. Right? So I'm going to look at an example. So here, I'm in the middle of solving a problem, doing a crossword puzzle, And you crossword puzzles. Okay, I need to know how many vowels are in a word, right? I have a string, and okay, count the number of vowels. So I create a private function. I call it vowel count, and then, well, what do? I mean, it's just standard stuff, right? I mean, you just go through each character in the string, and then is it an A, E, I, O, right? And then if it is, you increment the count by 1, and then you return that count when you're done. It's pretty straightforward, right? I mean, it's simple, but that method does not operate on any fields, instance variables of this class, right? So I can make it static, right? I could put in a different class and just call it from there. If we were in Python, I could just make it a regular function, right? And then just call it as a function. Clear enough?
You put this that class, that would be the class. We have put that data.
Yeah. So let's look at an old version, right? Well, what data? So in my string class, I can create a vowel count. Why in the string class? Well, because the data it's operating on is a string, right? And then I can, iterate over all things in the string, and then using the double principle, right? I say, I don't want to do all the work. You do some of the work, right? We have different objects to spread the responsibility out, right? And so I can ask the character, are you a vowel? Right? And then, my character class, I can just have is vowel. And it's a pretty simple method, right? What's that? Another class, right? But it's operating on data that's inside the class, right? Whatever, right?
Yeah.
And I'm not showing you the entire character class, right? I'm not showing you the entire string class, right? And now I want to use it. It's just, well, I should have said a word, but you basically, when you got that string, you just send it a message to tell me what your vowel count is, right? I'm getting the same behavior, right? So my crossword puzzle, some method that does some stuff, right? It's still doing the same still doing the same work, right? Still getting the same answer, but I structured it differently, right?
This is a function. You move the class, function that would also work.
No, because what's this, right? So this is operating on that particular character. That vowel count is operating on that particular string. Whatever we don't know what it's. I'm not showing you how it's structured inside, right? So is this better? If so, why? If it's a good idea, right? We talk about encapsulation. We just talk about, the heuristics. Do you want to keep data and operation together? And I'm doing that here, right? I'm putting a method in the string class because it operates on a string. It deals with string, right? I'm putting a method in the character class because it deals with a character. What do you mean a primitive? What language are we in? We'll get to Java in a minute. Okay, I want you to postpone that question. And that's a very, very important question. It has a big impact, right? So the first question is this better? But how? I mean, what's that?
Use that method times across the class, I guess, to have it in like one or two operations. Really a lot of effort to define string. It's easier to make a
So one of the things we talked about last week, why is all good? Reuse, right? Oops. Can we reuse this? Even if we make it public, we're not going to reuse it because you're not going to remember where it is, right? Can I reuse this elsewhere? Yep. Can I reuse this? Yep. Right? So all of a sudden, remember we talk about small little pieces, right? Breaking small pieces, we get things which are more easy to reuse. Let's see, is your native language English? How many vowels do you have in your native language? Oh, here we can now, by modifying this one method, right, we can support other languages, right? The other way, you're dead, right? Because you have to find a thing, right? And of course, if you do it there, you might have done it somewhere other place, right? And you're screwed because now you have to find them all and repeating yourself, right? So using this idea of, sending a message, right, to get your work done, right, leads us to, building small little pieces and we put the things where the data belong, right?
What do you mean by like the problem, like you can't find it?
Oh. Oops. How do you ever find that? It's a private function, right?
Yeah, and then only that object can use it.
And even if I declare it to be public, yeah, right? So, and who's going to look for that method in your crossword puzzle class, right? If you're thinking about a class assignment, you only got 5 classes. Think about, a company-wide project that has 5,000 classes. You're not going to look in there for that method, right? Right? Right. Okay. So you see these things start to fit together, right? By saying, I want the data and operations together, right? That means it gives me smaller pieces and it makes things a little more usable. Reusable, right. And now let's get to your question, right? Can I do this in Java? No, not at all, right? So in Java, first of all, you can't change string, right? You can't, any class in a JDK, you cannot change. Absolutely no way, right? Well, you can, by creating your own private little JDK, but then you're dead, right? Then you can say, well, maybe I can subclass string and then put it there. If I could subclass string, it still won't work because strings appear everywhere, right? And then you have to convert that string into your string, and you'll be continually doing that. And it's like, oh, it's a mess, right? Besides, you can't do it with string because string is final, right? You cannot subclass it. So you never do this in Java, right? Because you can't. And so in the Java world, you never even think about doing this, right? You're always creating utility methods. You're always creating a little private method to do this other stuff that does simple stuff, right? Anything that deals with the JDK classes, right? You never think about extending them. You never think about, oh, it would be nice if that class could do this for me, right? So what do? You create a utility method, right? A private little method or a static method that does it for you, right? So if you're a Java programmer, right, you never think about this idea of, oh, I want to use a default principle, have someone else do the work, because now it breaks things into smaller pieces and they can be used elsewhere. And always creating these utility methods over and over again until you get to larger things, right? Yes. Yes, but you don't have to go that far. In Swift, they have what they call extension. And so I can extend string and add functions to it. Kotlin, which is interesting because Kotlin compiles down to Java. We can add things. Here I'm adding a function foo to a string class. Right. So in Kotlin Swift, we can do this, right? In Python 2, you used to be able to do this, but you can't do it in Python 3. And in Smalltalk, they went better, and they gave you all the classes, right? So when you open up a Smalltalk browser, you've got all the classes. I mean, their array list. It's not some mysterious thing. You can go look at the source code. And they gave you a mechanism to put your changes to a class in a separate location so that you can give them to other people, right? But the big problem here is that one of the key things you want to do, right? You want to think about messages. You want to keep data and operations together, right? Is that Java works against you until you get the big, large things. When you're dealing with your classes, right, then you can do it. But the problem is you spent the last N years not being able to do it, right? So it's not your initial reaction. And that's one reason when I taught 535, I insisted we use Smalltalk because then I could, the first assignment would be go write some, add this method to integer, add this method to string, add this method there and there, right? To get them to build the idea, I can always do this, right? I need a isVowel, right, method and the character class, so go add it there, right? And now I can just send a message to the vowel or the character to see what it is. And This is easy to test, right? I can make sure it works. And if I want, once I realize that English is not the only language on the planet, I can modify it to work correctly with Unicode characters, right? It's simple to write, right? That's simple to write. That's simple to write. So the probability of errors is much less or easier to test. If I need to extend them, I can extend them and I can use them elsewhere, right? Can't do that here, right? We're screwed. I mean, we're just screwed in many ways, right? There's no reuse, right? How do I test this? It's private. I can't, right? I want to modify it to support other languages. I have to find it first, right? Right? So it's the idea that data and operations go together is critical, right? That's the main idea, right? And you send a message to an object to get work done, right? That's Alan Kay's main idea. And the way we're doing it here, right, is, I just send a message to the string to get the vowel count, right? It's a Dilbert principle. Let someone else do the work, right? Let the string class do the work. Let the string, and then the string, I mean, why should it know about vowels? What's a vowel? In English, there's only 5 of them, but other languages, there's other vowels. I mean, he can't even, he doesn't remember how many vowels are in your language, right? Yeah, 8 to 9, right?
Modify this
Right. What's that? What? And sometimes why, right? Right? But is the idea clear here?
So, like, in terms of, like, some sort of constant, now we're just keep, because you just have, like, a messenger force. But with these two,
Well, it's not like the question is about implementation details. How do I manage, right? In the Java world, it's like a class goes to goes in a file, right? The reason I do that is it makes it easier to find the classes, right? If I've got one file that contains 10 classes, how do I ever find it? Because then you look at the name of the file and it's like array list and it's got 10 other things in there. I don't know what's in there. Some other languages sort of bend their rules, but it now becomes code management, right? In Smalltalk, they don't use files. There is one file that contains everything. I mean, your goal in programming is accomplishing a task, right? So why are you mucking about with files? What do files have to do with writing a program?
having files.
So why can't your IDE do that for you? Yeah, but you have to create the different locations, right, and create the packages, but why does the program have to worry about that, right? That was a Smalltalk vision. It was like that's an implementation detail that the IDE can handle. So why is the programmer creating this directory and that directory to hold files? I mean, just
mean, you're skipping at the same time. Like, I don't know if this was a principle back when small talk was introduced, but another advantage to have stuff in separate files is easy to contain that. At least it seems like it would be, not just having a giant 10,000 like have to grab.
It solves some problems and creates some problems. And the problem you're thinking about was not a problem.
You're kind of working.
They were able to run it on machines in the 1980s, early 1980s, late 1970s. So that's a side issue, right? The main point here is, right? What's that? You do have thousands of classes, right? There's probably tens of thousands of them. No, they had solutions to it. I mean, but again, that's a side issue, right? This is the important message here is that we want classes to represent abstraction, right? The goal is to try and avoid utility methods and avoid data classes.
This and the amount of person is to send class crossword to someone else. This might not, because their final classes will be.
So yeah, so that's a problem, and different languages handle it differently. The Smalltalk solution is completely different than the Swift version. The Swift version, you package your code up and you package with it your extensions. That's it. The same thing with Kotlin, right? You can have extensions in one file, multiple files, but that becomes part of your project, right? And then if you then have a team, right, when you check out, you get those files with that project. And then it works, right? Smalltalk solution is different, but it has the same effects, right? There's a way of, here's my project, and in that project, I'll contain, these methods and these existing classes. And then when you checked it out, you got it all, right? Now, one thing this does do, if we go back here, right? Now our program gets spread out, right? Right. Before it was all in one class, in one method. Here it's better. How do I understand this? Well, I have to go to vowel count, and then I have to go to vowel count. Oh, I have to go to isVowel, right? Now the names are picked here, so you pretty much know what's going on, right? Vowel count. I mean, it's pretty self-explanatory, right? The only question is, how's it done, and what do we mean by a vowel, right? And you go there. Now isVowel, again, it's self-explanatory. The only question is, what is a vowel, right? Do we include Y or not? Do we include other languages or not, right? But the name, otherwise, the names are pretty self-explanatory. But it does mean, right, you now start to build up this program of multiple objects that interact together. Correct. A data class is just a class with just data. No behavior, right. No, in Java, a string has methods, right? You can reverse a string and get elements in or take them out. You can do all kinds. I mean, you go to Java and look at the string class, there's a bunch of methods in there, right? What's that? Integer in Java is, Java didn't want to go whole hog, so it kept some primitive types into the primitive type. Integer in Java is just a wrapper around int, so you can put it into a vector or array list. What's that? What's a Boolean in Java?
You just check the value.
Yeah. So in some languages, Booleans are actually a class, right? In Smalltalk, a Boolean is an actual class, and you can then implement methods on Booleans. Well, is it a class? So it's just some sort of primitive type, right then, right? In C Sharp, I don't know. In Smalltalk, it's object all the way down. So their character class is an integer class, right? I mean, what you used to think of primitive types in Smalltalk, there's a class, right, and instances of them. Yeah, I think that is a good place to stop.